Hello students, most welcome to Dr. Acharya Academy. Today I am going to discuss the kinetic molecular theory of gas. This is very important topic. This topic has been taken from the CBSE syllabus, part 1, class 11, unit number 5. Today's class number is 105. Previously, we discussed about the Boyle's law, Charles' law, and these laws are based on the experimental facts. And when we did these experiments, an important aspects of scientific method, and it tells us how the particular system is behaving under different conditions. Now, this experimental fact, which is already established, so the scientists want to know that why the system is behaving in that way. It means that whatever the experimental findings we have, and on that basis, the Boyle's law, Charles' law is established. But what is the system behind it so that the gas follows the Boyle's law and Charles' law? We can take on example that as per the gas laws, the pressure increase when we compress gas. But here we like to know that what happens at the molecular level when a gas is compressed. So a theory which was created as a model to better understand this type of observations which derived from the gas laws. This theory is called the kinetic molecular theory. So now we'll discuss the kinetic molecular theory of gas. Kinetic molecular theory of gas has a number of assumptions or postulates. We have to consider these postulates to explain the experimental findings of the gas laws. Number 1, gas consists of a large number of identical particles. It may be atoms or maybe molecules. And these identical particles will be very small, and apart from on the average that the actual volume of the molecules is negligible in comparison to the empty space between them. Then these identical particles of the gas should be considered as point mass. This is the first postulate of the kinetic molecular theory of gas. So when we consider the gas atoms or molecules are point mass, then these postulates explain the great compressibility of gas, because there in between the point mass there is the empty space for this compressibility of the gases. So with this first assumption of the kinetic molecular theory of gas, we can explain theoretically the compressibility of gas, what we experimentally found. Number 2, there is no force of attraction between the particles of a gas. That means whatever the point mass we considered, in between this point mass of a particular gas, there is no force of attraction at ordinary temperature and pressure. We have to mention this always, ordinary temperature and pressure. And this assumption supports that the gas expand and occupy all the space available to them. Because these particles, whether atoms or molecules of a particular gas, there is no force of attraction. So they can occupy any position in the space. So the expansion of the gas is explained clearly by this point number 2, that means assumption number 2 or postulate number 2, whatever you can tell, of the kinetic molecular theory of gas. Now postulate number 3. Postulate and assumption is the same in this kinetic molecular theory of gas we will consider. So point number 3, the particles of a gas are always in constant and random motion. It means that if the gas particles are at rest and occupied fixed position, then a gas would have had a fixed shape and which is not observed. It means that whatever we consider in these postulates, that particles of a gas are always in constant and random motion. And it is in random motion, that's why you will not get any fixed shape of the particles of a gas. So number 4 postulates, particles of a gas move in all possible directions in straight lines. And it is a random motion. And during this random motion, they can collide to each other and they can collide with the walls of the container. And when you collide with the container, then the pressure exerted by the gas. Number 5, collisions of gas molecules are perfectly elastic. Why you consider this is the perfectly elastic? Because before and after collisions among the particles of gas, that is the molecules or atoms, the total energy before and after of the collisions will remain same. And this assumption we can elaborate that there may be exchange of energy between the colliding molecules. That means their individual energies may change, but the sum of their energies remain constant. That's why the assumption is the collisions of gas molecules are considered as perfectly elastic. So if there is loss of kinetic energy, then the motion of the molecules will stop and gas will settle down. But practically it is not happening. So that's why we consider this assumption number 5 to make the collision of gas molecules, it has the elastic in nature. Now assumption number 6. At any particular time, different particles in the gas have different speed and hence different kinetic energies. So this assumption is reasonable because as the particle collides, what do we expect? That their speed also changing. So even if the initial speed of all the particles are same, but during the collision, they will have the different speed. And what will the result? The particles must have different speed and which go on changing constantly. So it is possible to show that though the individual speed are changing, but the distribution of the speed remain constant at a particular temperature. Always we will write this at a particular temperature. So from this assumption, whatever we understood, that the distribution of the speed will remain constant at a particular temperature. Now assumption number 7. If a molecule has variable speed, from point number 6 we understand this, then it must have a variable kinetic energy, because the kinetic energy has relation with the speed. Speed will increase, kinetic energy also will increase. Speed will decrease and the kinetic energy also will decrease. So as per this assumption number 7, here we can understand only about the average kinetic energy. So in this kinetic molecular theory of gas, the average kinetic energy of the gas molecules is directly proportional to the absolute temperature. So what we have seen, that on heating a gas at constant volume, the pressure increased. On heating the gas, so kinetic energy of the particles increase and they strike the walls of the container more frequently, and in that way the pressure increase. So during this discussion with the number of assumptions from the kinetic molecular energy of gas, whatever the conclusion of this, the kinetic theory of gas allows us to derive theoretically what is the molecular function behind the gas laws. And on that basis, that means on the basis of the kinetic theory of gas, calculation and prediction, whatever is made, it is consistent with the experimental observation, and in that way the correctness of the kinetic molecular theories of gas is established. I hope that you understand these different assumptions of the kinetic theory of gas, and this kinetic theory of gas is for the explanation of the experimental findings of the gas laws, and this will be helpful for your exam and your growing knowledge in the chemistry. I have also a podcast in the same name, Dr. Acharya Academy, and it is for the honors and degree level education. You can go through this for detailed understanding about the different parts of the chemistry. Thank you so much for watching this class.